zeros and x-intercepts?
They're all the same.
They're all the same. Very good. That's going to be really important in this lesson, so we have to know what roots, zeros, and x-intercepts are. So basically the point on a polynomial that cross the x-axis, and what is the equation of the x-axis?
Y equals 0.
Y equals 0. Good. Okay, so just filling it in here, we have the zeros of the function, the x-intercepts of the graph, and the roots of the corresponding equation, y equals 0, are all the same numbers. Okay, in lessons 7 and 8, which we're doing today, we're going to be looking at polynomial functions and how they look and what these x-intercepts, zeros, and roots represent as factors. So before we can do that, let's just go to the unique factorization theorem and just review or have a look at what a polynomial will look like when it's factored down. Okay, so we have a polynomial that will have a coefficient out front. Okay, and then we'll have its individual factors that will be multiplied together. If you were to expand, you would get the expanded form of the polynomial. Now, do you guys know, say if I had 3 of these factors, what degree I would have? So if I have 3 factors here, which basically mean I have 3 x-intercepts, what would be the degree? 3, because x times x times x gives me x cubed. Okay? And do you guys know what the a1, a2, a3, an would represent in these factors? What? Sorry, what did you say? Your constants. Good. In the factors, these are constants. If you were to take them out, like say I took this individual factor, it said x minus a1 equals 0, and this is some random number. Okay, let's say a 3. X minus 3 equals 0. What would be the value of x for that? 3. Okay, so that would be my x-intercept from that factor. Yeah?
What's the subscript?
Where are you looking here?
Like A2, like why are they so small?
Right here? In here? They're just telling you that it might be a different number. So it's not necessarily the same.
Okay.
And then an, it just depends on how many factors we have to determine what that could be. Okay, but these numbers will be dependent on the original polynomial that we start with. And this is just the basic form of what a polynomial looks like when it's factored. You're going to have a coefficient out front, and then a list of factors where the number inside helps us determine the 0 or the x-intercept or the root of that polynomial.
Okay, thank you.
So, no problem. So there's a few important points here. So every polynomial can be written as a product of its factors with the leading coefficient. That's basically what this is saying right here. We have factors that are multiplied together. The polynomial is the product of all those. Okay, every polynomial function has the same number of factors as its degree. And so when I asked you guys if I had 3 factors, what degree it would be, if you have 3 factors, you have degree 3. If you had 4 factors, what would your degree be? Degree 4. Because you'd have x times x times x times x. So you get x power 4. So in this lesson and the next lesson, we're going to be looking at coefficients in front that are positive or negative 1. Whereas in lesson 10, we're going to be looking at coefficients that could be anything, and we're going to be solving for that c value. Okay, but we're going to start easy. We're going to just look at the positive and negative polynomials. So for this first example, we have a polynomial that's drawn for us on the graph, and it's defined by x cubed minus 2x squared minus 5x plus 6. So looking at this graph, let's first just find what are the x-intercepts, just by looking at it. Where does this polynomial cross the x-axis?
-2.
Negative 2, positive 1, and positive 3. So if we have those x-intercepts or those zeros, we can take those and write them into binomial factors. Okay, so for example, if x equals -2 and I wanted to set that equal to 0, I would add the 2 over, and I would get x plus 2 equals 0. So the factor from my 0, which is negative 2, is x plus 2. It's basically the opposite sign. What's my factor from or your 0 being 1? X minus 1, good. And what's the factor? X minus 3. Awesome. So if I were to take those factors and I were to write the polynomial in factored form, I'm going from this expanded form to factored form, and rather than going through the process of what we did yesterday or the day before that, finding which 0 would give me a remainder of, which x-intercept or which potential 0 would give me a remainder of 0, then going through synthetic division. Okay, just by looking at the graph and finding the x-intercepts, I can write my factors, and voila, I have factored my polynomial. So this is a major shortcut if you're asked to factor a polynomial. You can plug the graph into your calculator, find the x-intercepts. From the x-intercepts, write out the factors, and you're done. Now, if you ever wanted to verify whether you factored it correctly from your first polynomial statement to your factored form, what you could do is put this graph in y1, the factors in y2, and if you get the same graph, then you know you did it right. Now, what happens if you get a different graph, like this maybe? Pardon? The signs are wrong, yeah. And what do you notice about this arm? It's reflected. And this arm? It's reflected. Have I gone through the same x-intercepts? So going back to the transformations unit, if I were to apply that reflection on this graph, what would I have to put in front? Just put a negative. Okay, but is that the case for this polynomial? No, it was positive. My leading coefficient was positive, so my factors are also positive. I don't need that positive in front. And you would have realized that the graphs don't line up anyways. Okay, so just to recap, you can graph the function, look at the x-intercepts, from the x-intercepts create factors, and from there state your polynomial in factored form. Now you guys get to do a little bit of graphing. So in your y1, could you guys please put that equation in there? So we have negative x cubed plus 4x squared plus 7x minus 10. Are you okay, right? Okay. So I've graphed my polynomial. We can clearly see the x-intercepts, but I can't see the minimum or the maximum point. So if you did want to create a better graph, we could change our window settings. In this case, I'm going to move my x-min into -6 maybe. X-max seemed okay. My x-min maybe down to -20 and my y-max to +20. And let's just see if I get a better picture of what's happening. That's a bit better. So now you're seeing a better shape of what this polynomial function looks like. If we are asked to factor this polynomial, and we're using our calculator, so not algebraically, again you put it into your y equals, and to find your x-intercepts, if they are exactly on a value, so they're not a decimal, a little shortcut is to go second into your table, and you can locate your x-intercepts by finding where y equals 0. So here we have -2 and y is 0, so one of my x-intercepts is -2, sorry, squeaky marker. Okay, another one is at +1. And if you're unsure if there's more, you can go back to your graph and have a look. But if I keep going, 5 and 0 is another one. And as a refresher, what's the other way you could find your x-intercepts in case they weren't exact values like that? Second, trace, number 2 for your zeros. And then say I'm just finding that middle one, I would go left bound, enter, right bound, enter, enter one more time. And we get 1, 0. Okay, so that's 2 ways you could find your x-intercept. Just refreshing, reviewing from lessons before, how would I solve for this algebraically? How would I prove that 1 is an x-intercept? What could I do with that 1? Good, I would sub it into all the x's in the polynomial. In other words, I would solve for p of 1. And if we get 0, we know that 1 is an x-intercept, and x minus 1 is a factor. Now, how do I know to guess 1 or negative 1? Well, you look at the constant in the polynomial, and 1 and negative 1 will be factors of every single number that we ever have for a constant. So that's why it's good to always pick 1 or negative 1, because it might be a 0. Other than that, factors of 10 would be 1, 2, 5, and 10. So you're just taking a stab in the dark, plugging it into the polynomial. If you get 0, then you know it's a factor. But as we've seen graphically, that's a bit of a shortcut. So if you're a little unsure which number to pick, you could always refer to your calculator and find your x-intercepts. And from there, we can put those into factors. That could have been really bad. Sorry about that. Straighten things out. Okay, sorry. We found our x-intercept, so we can write it now in factored form. So our polynomial will be equal to, what's the factor from negative 2? X plus 2, factor from 1, x minus 1, and the factor from 5 is x minus 5. Now, just to show you guys a comparison, I'm telling you I've made a mistake intentionally right now. I want you guys to put into your y2 the factors. And you guys are already ahead of the game, which is great, and I think Joseph's already on it too. So if I put in the factors that I just found, x plus 2, I'm just going to see if I get the same graph. So x plus 2 times x minus 1 times x minus 5, and I graph it. Brett, he's on fire here. Oh, it's reflected across the x-axis. So because of that, I know that my sign on these factors are not correct. Maybe let's just try putting a negative in front. So a little trick, you can go second insert, and then negative. You don't have to rewrite it all. Now let's see if we get the same graph. I'll show you one more time.
You know that?
I didn't know.
Second insert?
I didn't know that either.
Yeah, I always just re-enter all my numbers.
Yeah.
Okay, so if you go to y equals again, I'll just delete this.
Second delete is second insert, you can
So-
put anything in front.
Second, and then insert, I'm going to put a negative in front.
Yeah.
So I
So you
don't
can
have
do
to
that with
rewrite it all.
anything.
Anything. Yeah, so say that you wrote something in your calculations wrong and you just need to insert a bracket.
And then I delete everything.
I would have
Yeah.
saved time, like, I would have saved at least,
Where was that in grade
Yeah.
10?
seriously.
Okay, so let's just see if we get the same graph.
Just mind blowing.
Yeah, this is the simplest thing, dude.
Everyone's just.
Like,
Like, what?
it's so obvious now too, like INS, like, come on.
Okay, and we found that negative did make a difference. And also, Joes, you were probably looking at the original polynomial and you checked out that leading coefficient.
Yeah, it's a negative.
Saw it was negative, we need a negative. Okay? So let's just talk about the arms on this polynomial. The left arm is here. Okay, this is the left arm, it's going to keep going up. Hey, would you say it's rising or falling? Okay, is this one going up or down? It's rising. Okay, the right arm, which is here, is going down, so it's falling. And let's just
This way and this way.
let's just talk quickly about slope of lines, okay? If we had a graph here, and I had a line that looked like this, would I have a negative, guys? Would I have a negative or a positive slope? Negative slope. Okay, so we would say that this polynomial is negative. The leading coefficient is negative, which we saw, we've already talked about that. Okay, and we can kind of describe the slope also as negative. So what I want you guys to remember is if you have a negative leading coefficient, you can kind of go back to Math 10 and think about slopes of lines. And if we have that the left arm is up and the right arm is down, okay, it's going to be negative leading coefficient. Okay, it's a negative polynomial. Yeah?
Just when you're doing this,
Mm-hmm.
what happens if you get an x-intercept of 0? What do you put for the factor?
X.
Just x?
Yep. Okay, and how about after we do all the examples, I'll talk about that one a little bit. Okay, what would you guys say the degree of this polynomial is? You can look at the original equation or our factors. Okay, it's odd and the degree was 3, if you wanted to be more specific. So let me just cover this up and I'm going to put an example on the board. Okay, say I have this polynomial that's factored out and I need to determine the zeros. What do I get from x plus 4? What's the 0? Negative 4. This one? 3. And how did we get these? Well, basically we set the factor equal to 0 and we solve for x. So I subtract the 4 over and I got my x-intercept of negative 4. And you do the same step for this one. The same goes for a single factor x. Okay, you have to set that factor equal to 0 and isolate the x. Well, we're already done. Our 0 is 0. Our x-intercept is 0. So if you ever have a factor that is just a single x, okay, the 0 or x-intercept will be 0. Does that help a bit, Justin?